Welcome to this video tutorial where today we are going to be exploring the concept of perpetuities. Now, a perpetuity is an investment account whereby it is earning regular amounts of interest and having regular withdrawals taken out from it at the same time. Now, the difference with perpetuities to other investment accounts is that the amount of interest that it earns each compounding period is the exact same as the amount of money that is withdrawn from the account at each compounding period. That means that the net total change of this perpetuity is always going to be zero. So at the end of each compounding period, that initial amount invested is going to remain the same, because any interest that was earned was then removed. When we are looking at perpetuities, we can follow one key formula, which I like to call DIP, or D equals I multiplied by P, where D is the amount that we can withdraw, or our amount earned from this account. Our I is our interest rate. Importantly, it's per compounding period. And our P is our principal, or our original amount invested. We are going to be having a look at 3 different examples during this video, where we will be looking at how to calculate each of these 3 variables in our perpetuity formula. For our first example, we are going to be having a look at this question here, whereby an individual wishes to invest $42,000 in a perpetuity that will earn 6.15% per annum, calculated quarterly. Periodic payments are made quarterly from this investment. How much will they receive from this perpetuity each quarter? So we are going to begin by defining our variables based off the information we've been given in the question. We can see that original investment of $42,000 has been made. This will be our principal. We have been given an interest rate of 6.15% per annum, and these are going to be calculated quarterly. So we need to find that quarterly interest rate. We want to see how much they receive from the perpetuity each quarter, so our D value is going to be our unknown. We can then substitute these values into our perpetuity formula, where we can have D equals 0.0615 on 4 multiplied by 42,000, which will give us a final value of 645.75. So we can say overall for this problem that they will receive $645.75 per quarter. And that is how we would calculate our unknown payment amount, or D, when working with the perpetuity formula. For our second perpetuity example, we are going to be exploring calculating the unknown principal value, or the initial investment amount. Using this example here, we've been asked how much money will need to be invested in a perpetuity account, earning interest at a rate of 4.2% per annum compounding monthly, if $200 will be withdrawn every month. So like with all of our financial mathematics questions, we are going to start off by seeing what variables from our perpetuity formula we can define. The first thing the question asks us is how much money will need to be invested, so our principal amount will be our unknown. We've been told that we are earning interest at the rate of 4.2% per annum, and this is being compounded monthly, so we're going to divide that by 12. Then we are told that we have $200 withdrawn every month, so that will be our value of D. So we can take these and substitute them into our perpetuity formula, whereby 200 equals 0.042 on 12 multiplied by P. Now to get our value of P by itself, we are simply dividing both sides by this fraction here. So it would have a p-value of 57,142.86. So therefore, for this example, $57,142.86 will need to be invested. Now, when approaching perpetuity problems, we don't always have to use this dip formula here. As you can see in this little triangle I've set up, you can rearrange the formula D equals I multiplied by P for any of the three variables. So you can either begin your perpetuity problems by having the formula already with the correct unknown variable as the subject of the equation, or you can rearrange the formula as you go. Both of these options will still get you to the same answer. For our final perpetuity problem, we are going to be exploring how to calculate the unknown variable I. And we're going to be using this third example here to help us out. Now this example states, a university faculty has $30,000 to invest. It intends to award an annual prize of $1,500 to a student using the interest from this investment. If the award is to be made in perpetuity, what is the annual rate of interest required for this investment? Now, as always, we are going to start by defining which of the three variables we've been given in the question. We've been told initially that there is $30,000 to invest, so this will be our principal value. Then we've been told that it wants to award a prize of $1,500 to a student, so that will be our D value. We want to find the annual interest rate that is required for this prize. Note that this particular example is working in a per annum interest rate, so we aren't going to have to do any changes to our solution at the end. Now that we've identified two of our three variables, we can substitute it into our perpetuity formula, where we will have 1,500 equals I multiplied by 30,000. Now to get our I value as the subject of our equation, we simply divide both sides by 30,000 to get a value of 0.05, which will be the same as 5%. So for this particular example, we can say that the rate required is 5% per annum. Again, we could have started this problem by rearranging our perpetuity formula to get interest as the subject of the equation, and that will have gotten you to the same answer as well. Please note that if you're given a problem like this in the future whereby your perpetuity is not on a per annum basis, then this solution you are going to end up with will be the interest rate per that compounding period. So you will need to multiply it by the number of compounding periods in a single year in order to be able to get your final interest rate per annum. Great job of making it through this video tutorial on perpetuities. I hope that is going to be beneficial for your applications of financial mathematics. Make sure you let me know how you went in the comments below and if there's any other topics that you would like to see covered. Happy solving!